Okay, so last section we're going to look at this week is 8.4. And 8.4 is on two more things that we can do with complex numbers if they're in trig form. That's raising to a power and taking a root. Now, when we multiplied and divided yesterday, it is convenient to have numbers in trig form, but it isn't necessary. You can multiply and divide in rectangular, and that's what we learned much earlier in the year. Raising to a power, you can't always easily do in rectangular. You're squaring something, cubing something, that's pretty, you can do that. But if I have to raise something to like the 95th power, there's just no way you're going to be able to take and write something 95 times in parentheses and FOIL them all out. So there's got to be a much better way to raise something to a power, and that's called de Moivre's theorem. Okay, so we're going to look at a couple examples. We're not really going to prove the theorem, but we're going to do something that would suggest what the theorem would be, and I'm hoping when you see a pattern, you'll know what to do. So let's look at taking that complex number and raising it to the second power. So this entire thing, okay, raise it to the second power. So you'd have r cosine theta, I sine theta, take all of it, and square it. Okay, any questions on what we're going to do? And we're squaring it in trig form. Okay, what I'm going to do is I'm going to write that out, because when I have to do FOIL or distributive properties, sometimes it helps me to just kind of see it. So instead of writing it to the second power, I'm going to just go write it twice. So r cosine theta plus I sine theta, r cosine theta, I sine theta. How many factors do you have there that are being multiplied together?
Technically multiplying only like two, because you're multiplying r and r, and you're adding. You're adding.
How many factors? There are 4 factors. 1, 2, 3, 4. All 4 of those need to be multiplied together. Now, does the order you multiply in make a difference?
No.
2 times 5, 5 times 2. No. So let's just deal with multiplying r times r right away. So r squared. Okay, that takes care of the others. Now, the cosine plus I sine, cosine plus I sine, that has to be FOILed. Okay, so let's FOIL that. Remember, you still have a parenthesis there. Okay, that's still a parenthesis. And what's cosine times cosine?
Cosine squared theta.
So hopefully we end up with a sine squared somewhere, and then a cosine squared plus sine squared is 1. Let's see what happens. So cosine squared, we have cosine times I sine, and another cosine times I sine. So how many of those do we have?
2.
So we have,
2 I sine.
I'm going to write it like this. It's 2 of the cosine times I sines. So we have 2. And you'll see why I'm going to write it like this in a second. We have 2 of the cosine I sines. Okay? Just put it in a little different order to make it so you might recognize something. And then I sine times I sine is what?
Negative minus sine squared theta.
That's a minus sine squared theta when the I squared is changed to -1. So cosine squared, okay.
I'm pretty sure there's something that we can change the 2 cosine sine thetas to.
Yeah, so let's see
Forget what exactly it is.
what's going on here.
I know there's
I
something
mean,
that we can.
you have cosine squared minus sine squared, so like,
There's got to be some stuff that simplifies there. Oh, I remember now. I have to think for a second. Does this look familiar at all?
Yeah, I'm pretty sure there was something that we could change that into.
That is something. We wrote it as 2 sine cosine. This is 2 cosine sine, but it is the same thing. Yeah. That's a sine 2 theta. Yes. Sine 2 theta. And then this is another identity. Cosine squared minus sine squared. Does anybody remember what that one is?
negative 1?
No, the sine squared plus cosine squared is 1. Cosine squared minus sine squared was something else we did.
Remember, like, tangent squared is secant squared is another one.
Next section. It was in when we did the sum and difference identities, double angle identities, 7.5. What is cosine squared minus sine squared? It was on page 415 in the book. Yeah.
2 cosine squared minus 1, or 1 minus 2 sine squared.
Nope, this is not a Pythagorean identity, this green one. Well, that identity is not going to help us. Yeah? Cosine squared minus sine squared is cosine 2 theta. What's underlined in green is cosine 2 theta. What's underlined in red is sine 2 theta. And that's what you get when you take the original number and square it. So it goes from r cosine theta, I sine theta, to r squared cosine 2 theta, I sine 2 theta. Now, based on that pattern, what do you think z cubed would be? Yeah?
R cubed cosine of 3 theta plus
Yep.
I sine 3 theta.
Right. Gives us a very quick way of raising a complex number in trig form to a power. Basically boils it down to doing 2 things. Raising the radius to the power and multiplying the angle by the power. So now if you ask me to do something like 2 plus 3i to the 20th power, there's no way you're going to be able to write 2 plus 3i and FOIL it 20 times. But if you change it to trig form, the answer is going to be whatever you get for the radius to the 20th power. We could just leave it like that. And then whatever you get for the angle, it's going to be multiplied by 20. So 20 times whatever you get for your angle plus I sine 20 times whatever you get for your angle. You just have to figure out what your angle is and do that part out and figure out what your radius is.
Mind if I write something up on the board real quick about that?
Sure.
Good. From what I can see here, it's the same as what we were doing yesterday with the R on
Oh, treating it as like what we did yesterday? Yep.
Yeah, and with the R1 plus, or no, not plus.
Times. Yeah.
R1 times R2,
Yep.
and then the cosine theta 1 plus the theta 2,
Yep.
like this.
The only difference is today, because the R1 and R2 are the same, we just say R squared. And since theta 1 and theta 2 are the same, when you add two things that are the same, you're just doubling it. That's where the 2 comes from. Yeah. Yeah, that's a good, yeah, perfect. Thank you. And then if you did it a third time, that's where the 3 would come from. Or if you multiplied the same, 5 times, R times R times R times R times R 5 times, it would be R to the 5th. Yep.
It's the same exact thing. It's
Yep.
just
So this is de Moivre's theorem. So as long as you're raising to an integer power, this doesn't work if you're raising to like the 1.4 power. Right? We don't really look at that in this class. But as long as you're raising to an integer power, you raise the radius to the power, and you multiply the angle by the power. All right, so this is going to give us a really, really quick way to raise numbers to powers, no matter what the power is. And it's going to eliminate all the foiling, I squared, all that stuff you would get. Now, if you just have to, like if I just had to square something, I probably wouldn't use this. Maybe even cubing, I still do it the old way. When you start getting higher than that, this is way, way more efficient. So that's de Moivre's theorem. So let's try an example. And it is important to understand de Moivre's theorem because when we do roots, we're going to do roots next. Roots are harder. But if you understand de Moivre's theorem, that will help. All right. So this is only cubing. So it wouldn't be that bad to do it by hand. But let's practice using de Moivre's theorem. Okay. What do you have to do with your complex number first if you want to use de Moivre's theorem? Yep. You got to get that in trig form. Okay, so getting trig form, that's going to start to become real quick. Okay. What's your radius if you have the number 1 and root 3 for the two sides?
2.
2. Square that, you get 1. Square that, you get 3. Add them together, you get 4. You take the square root. Okay, what's the formula that we're going to use to find theta based on the quadrant we're in? Yep. Inverse tangent of y over x. Hopefully you recognize root 3. That's always a nice number when you're dealing with tangent. So inverse tangent of square root of 3 gives me 60. Yep. Okay, now I've got my number in trig form. R cosine 60, I sine 60. And what power are we raising that to?
we're raising it to the third power.
Third power. What's going to be my radius when I raise this to the third power?
The radius is going to be 8,
Radius is going to be 8,
and the degrees is 180.
and the degree is 180. Yep. And that's how you write your answer in trig form. Now, let's say I asked you to go one step further and convert that to standard form. What's your first step to take what's in trig form and change it back to standard form, which is going to look more like this?
going to put it back into the other form, you've got to distribute the
Yep. Distribute the 8.
which is going to just get you a -8 because the sign cancels out to 0.
Right. The cosine of 180. Think of where cosine is on the circle. Cosine is over here. The x value of that is -1. That's 8 times -1. So that's -8. Now think of the y value of 180. The y value is 0. If you distribute that out, the sine of 180 is 0.
8 times 0 is 0.
Is 0. So all you get when you convert that back to standard form is -8. You could put plus 0i, but you don't need to. And you're not always going to have to change it back to standard form. Sometimes it's fine to leave your answer in trig form. I'm just showing you how to do the whole thing if they ask you for it. Okay. Any question on that? Yep.
So you just, like you can kind of inference it, but basically to do the rectangular form, like that form, versus I minus the trig form, you just like figure out what each factor is going to be, and then you wait.
To get it out of trig form is just to distribute
Oh,
the opposite.
Yeah, just distribute.
so you wouldn't actually do the -1 plus root of 3i.
Well, no, so that was 1 plus root 3i, that was the original problem.
Yeah.
So if you raise that to the third power, this is the answer you get in trig
Yeah.
form, this is the answer you get in standard form.
I thought it was minus trig form.
Minus trig form? No, just a
Yeah.
indicator of what format that is.
Go with it. Thank you.
Yep. All right, let's try this one. So this is one I definitely would not want to do to the 8th power by hand because there's a lot of foiling that's going to go on and there's a lot of chance to make a mistake. Yeah, I think we did one with numbers like this in the homework. What's my radius going to be?
I'm pretty sure the radius is going to be 0.
No, because that would be 1. I think it's going to be, because like the things we already did this before, so a -2 over 2 is a half, and then another -2 over 2 is a half.
It would be
So if it's
One.
yeah, but like if you do, yeah.
Well, this is a point on a certain circle. It's -√2 over 2, comma, √2 over 2. What kind of circle is that coordinate on? It's a common,
45.
yep. Well, radius first, but we'll talk about the angle in a second. But you are right. Yeah,
Just be 1.
the radius here is 1. Okay, that's -√2 over 2 up √2 over 2. If you square those, you get 2/4 plus 2/4. That's 4/4. Take the square root, it's 1. Now the angle, you can do inverse tangent of y over x. And then add 180 because you're in the second quadrant.
is
Or
going to be
you can just recognize that you've gone left and up the same amount. So it's a 45-degree angle in the second quadrant, which is 135.
yeah.
Okay, let's write that out. So you really don't even need r because r is just 1. So it's cosine 135, I sine 135, and you're raising that to the 8th power. So what's your radius going to be when you raise that to the 8th power? Yep, it's still going to be 1. That's not going to change at all. So radius is 1. I just need my angle.
The angle is going to be 1080.
And how did you get that?
Multiply the angle by 8.
Okay, multiply your angle by 8. Now, most of the time, they're not going to have you leave an answer like that. So what can you do to make that angle smaller?
You can do minus 360 over and over again.
Yep, we could just do minus 360, and eventually we're going to get an angle of 0.
Are we gonna get a formula in like before the end of the year for like? Sorry, does like the minus 360 thing? Is there a formula for that? That like it just finds out like for you like minus 360 like x or something? Like is there like a formula for that, or is it just the only way to do it is manual?
Well, I recognize 360 as, I recognize a 1080 as 3 rotations. So I know it's 3 full rotations, so I knew it was 0 right away. But no, other than that, there's nothing.
Oh, yeah.
If you were to put it back into standard form,
Yeah, what would that be in standard form? What's the cosine of 0?
that's 1, and
That's 1.
and sine is 0, so it's just 1
So we just get 1 and then,
plus 0 I.
no, the cosine of 0 is
Cosine
the
of
x
0
value.
is 1. Well, the sine is going to be 0.
So you get 1 plus 0i, or 1.
Sorry, it didn't like cosine 0 I can understand, but sine of 0.
The y value for the coordinate at 0, and the y value is a 0.
Okay, so the x value for 0 is
1.
y.
So that's a unit circle. On the unit circle.
Yes. Oh, okay.
Yep. Now, look back at example 1. Let me put the whole thing on the screen. To get this, we cubed that. What would you do to this to change it back to that? So instead of going from this to this, what if I want you to go from that back to that? Yep.
Wouldn't you cube root it?
You would cube root it. Okay, so the opposite of cubing is taking a cube root. Now, whenever you take a root, well, let's start with square root. When you take a square root, how many answers are there?
There's 2.
There's always 2. When you do a cube root, how many answers do you think you get?
1.
3.
Oh.
Right? There's always as many answers as there are roots, as the index of your root. So if you take the cube root of -8, one answer is -2. -2 times -2 times -2. The other answer for the cube root of -8 is 1 plus root 3i. And there's one more answer if you take the cube root of this number.
Well, I was thinking first of all that it's just like I square root of 2.
So hold on one second. Does anybody know what the third root would be? Yeah? 1 minus the square root of 3i. So we've talked about complex numbers before. They usually come together in conjugate pairs when you're getting answers. So the 3 cube roots of -8 are -2, 1 plus root 3i, and 1 minus root 3i. In general, I'm not going to have you do a problem probably above a cube root or a 4th root on the test, because it starts to take longer the more roots there are to find. Okay. So if you take the cube root of -8, one answer is 1 plus root 3i. Okay.
That was bad.
All right, so roots. So this is the last thing that we're going to do with complex numbers. Okay, we've done multiplying, dividing, raising to powers. Roots is going to be the last one. This is basically the equation you have to set up when you're trying to find a root. Okay? If I do it with numbers, I think it'll make more sense. So let's say you wanted to find a square root of the number 9. Okay? So you wanted to find the square root of the number 9. If you fill in a 2 for n and a 9 for a, and you can figure out how to solve that, that will answer my question. So fill in a square root for n, fill in a 9 for a, and if you can figure out how to solve that equation, you'll be able to tell me the square root of 9.
It's
3.
Yeah, 3 and negative 3.
plus or minus 3.
Plus or minus
Yeah.
3. Now, what we're going to be finding roots of is not a number like 9, but a complex number. Okay? So what if I wanted to find the square roots of like 2 plus 3i? You're going to set it up exactly the same way. You're going to put the type of root you want to find here. Square root, cube root, fourth root will be the most common on the test. And over here, you're going to put the number you want to find the root of, which most of the time will be a complex number, like 5 plus 7i. And you have to solve it. But what format do you think we're going to have to put our complex numbers in to make this work? Yeah?
It's a question I'll answer, but like begin the unit. You said the absolute value of a plus bi equals like a squared plus like b squared. So like, is that like related to this? Like where it's
Yes, it's going to be related to it on the left side.
and the other question: are we going to be doing like log stuff? Because I know that like
No,
oh,
no worries. So what format do you think our complex numbers are going to have to be in to make this all work? Yep.
We're going to have to put it in trig form.
They're going to have to be in trig form. Okay.
And
That means the left side has to be in trig form and the right side. If they're not both in trig form, it doesn't work. Okay. So we're going to start with this basic equation every time, but the z and the a have to be in trig form. Okay. If you happen to be solving the equation that's equal to 1, you can just say finding the roots of 1. Or in our book, you might see them refer to the word 1 as unity. So if they say find like the fourth roots of unity, it means find the fourth roots of 1.
it's
Just like the
still
number.
just
The
going-
number 1.
It's just going to be 1 and negative 1.
Well, if you're doing fourth roots, it would be 1 and negative 1, but there are 2 other answers, which I think we're going to actually do that problem right now. We're going to find the fourth roots of unity. Yep. So remember, that's the key. There are always as many roots as the index of the root you're trying to find. All right, so I'm gonna write the steps out. Sometimes I debate whether I want to show you the steps first or kind of do a problem at the same time, because the steps alone, it's kind of like writing out the steps for how to do the quadratic formula. It's just a lot easier to see it being done. Okay. So I'll give you the steps, and we're going to kind of do one at the same time. Okay, so we're trying to solve this equation. That's what that step means. You gotta solve that equation, but remember, a and z can be complex numbers. We're not dealing with just the real numbers anymore. We're dealing with complex numbers. That's what this means. A and z are elements of the complex number system. You need to rewrite that entire equation in trig form. Z to the fourth equals 1. Which side has a variable on it? The left or the right? The left. So the left-hand side is going to still have variables on it when you rewrite it. The right-hand side doesn't have any variables. So let's start by writing the number 1 in trig form. Just the number 1. If you're confused because it doesn't have an imaginary part, then think of it as 1 plus 0i. It's a very easy number to write in trig form. What's the radius of the point 1 and then 0i?
1.
Radius is 1. And the angle, you don't need inverse tangent y over x. It's on an axis.
0.
The angle is 0. It doesn't get much easier than that one. Okay, in terms of finding the radius and the angle. That's going to go on the right-hand side. So r, even though it's a 1, I'm going to write it. Okay, so r cosine theta, which we know theta is 0 plus I sine 0. That's the right-hand side. Now, the left-hand side is something raised to the 4th power. Do we know what we're raising to the 4th power? No, that's what we're solving for. But we're going to solve for it in trig form. So rewrite z in trig form. There's not a lot you can do. You don't know the radius, you don't know the angle of z. That's what you're finding. So just use variables. Z is going to have a radius, and it's going to have an angle. That's all I know about z. It has a radius and it has an angle, and I'm going to raise it to the 4th power. All right, so I'm going to reword this. We're going to rewrite z. So A comes from the number given. In this case, the number given was a 1. Okay, we'll do a problem in a minute where the number given is a -1, or -8, or 1 plus I. Okay, but this is the last thing we're doing. We'll practice a few of them. Okay, so A comes from number given, and Z, you don't know anything about it. So you pretty much have to leave it as all variables. Okay, now, what can I do on the left-hand side that we just learned? Yeah?
Now you can do theta plus 4 for cosine and sine, and then you can do.
So let's start with R.
Yeah,
R to the 4th power,
And
cosine
Theta
4 theta.
plus I sine 4 theta.
Yep. That's what the left-hand side turns into. I usually jump to that step right away. R to the 4th, cosine 4 theta.
And the other side, you can get rid of 1.
Yeah, we're just going to leave everything the way that is.
Alright.
Don't change it. I know it's only a 1 and a 0 this time, but it's not going to be a 1 and a 0, and then you're going to need it. Now, you've got to make the left-hand side equal to the right-hand side. How many factors are on the left?
2.
2. How many are on the right? 2. One of the factors is a radius on the left. One of the factors is a radius on the right. One of the factors has an angle in it on the left. One of them has an angle in it on the right. So you're basically going to set what I just underlined equal to each other. So the radius on the left has to match the radius on the right. Once you solve that, that's going to be the radius for your answer.
Which is the same exact thing.
It's just going to end up being a 1. Yeah.
And then cosine 4 theta equals cosine 0.
So you set the angle on the left
Oh.
equal to the angle on the right. But when you're doing a 4th root, how many answers are there?
4.
There are 4 answers. So the radius is going to be the same in every answer. That never changes. What does change is the angle. So I'm going to show you what you have to add to this. And it's kind of like something we did before, like a 2 pi n
Yeah.
or something like that. But that's the idea to get the other answers. Yeah?
We're kind of like pretty much back to where we were at the top. Instead of z to the 4th equals 1, it's just r to the 4th equals 1.
Instead of z to the 4th equals 1. Yeah, yeah.
Yeah. So, will that always, that won't always.
Won't always be a 1.
Okay.
I'm going to do one in a minute where it's not.
But like, would we if since z is always going to be the variable, we could do the one, do all the stuff for the right side, but then could you skip all the stuff on the left and just write r to say it's the 5th or whatever?
But that's what ends up happening on one side. You end up with r to the power equals the number they gave you. So you really can get that side right away. Now, the other one, it's going to have a number times theta. I don't know what that number is going to be. It's going to be whatever the power is they want you to raise to. In this case, it was 4. plus. That's what you have to add on the end of it. And we've done that kind of thing before. So we get all the answers. We got to put a plus 2 pi k. We might have said 2 pi n. It's the same thing. Now, what does k equal? Okay. You're going to have a single answer for r. That's going to be the same in all 4 answers. So we can start writing our answers. We're going to have a 1, a 1, a 1, and a 1. It's going to be the same r in every answer. Okay. And we could also set up where we're going to fill in our angles. So this is how all the answers are going to look. Okay, we just have to figure out what the angle is going to be in all 4 of them. So an nth root always has n answers. Fifth root, 5 answers. Cube root, 3 answers. To find all the answers, you're going to plug in different numbers for k. You're going to plug in integers. You're going to plug in every number starting at 0 and going up to 1 less than your root. What type of root are we doing in this problem? We're doing a 4th root. So you're going to plug in 0, 1, 2, 3. That's how you're going to get your 4 answers. Yes?
What's the formula? What's the formula up there? Is it like k to the n equals nkm?
No, that's it.
Yeah.
So r to the n equals the number they give you.
That says number.
And then n theta equals, and I changed my notation a little, it's just like that.
Thank you.
Yep.
And then k we find from
That was all. Yes,
It's
oh,
basically whatever the n is.
whatever the number is.
No, whatever the power is minus 1, that's up to where you're going to.
So you're gonna know this theta right here. That's the angle that you found. Okay, we found it to be 0 degrees in our problem. All right, so what I usually do before I start plugging in for k, it's easier to get this alone. So how would I get theta by itself so the 4 is not next to it? Yeah, divide both sides by 4. So your formula for theta, just leave the 0 degrees, but it's 0 degrees plus 2 pi k over 4. And let k be 0, 1, 2, and then stop at 3. And that's how you get your 4 answers. Now you could do 360k, which
might be easier.
in this one, I mean, it's 0, so 0 radians, 0 degrees is the same thing. I'm going to put 360 above it. Let's do it in degrees this time and get our angles. Okay. What's 360 times 0?
That's going to be 0.
Plus 0.
0.
Okay, that's your first angle.
It's going to be exactly what we started off
Okay.
with.
Now plug in 1. What's 360 times, what's, put 360 right here. What's 360 times 1?
360.
Plus 0,
360.
and then divide by 4.
90.
9. Now plug in 2. What's 360 times 2?
720.
720 plus 0?
720.
720. And then 720 divided by 4.
180.
180. Yep. We plug in 0, 1, 2. Now we plug in 3. What's 360 times 3?
1080.
1080 plus 0.
1080.
1080. And 1080 divided by 4?
270.
270. Yep.
So we have
And those are the 4 answers for whatever the question was asking. The 4th roots of the number 1.
when we put it in basic or back into the complex numbers or normal numbers,
Yeah.
we'd have 1 on top.
Yep, when you change this back to standard form, the answers, which I'm not going to do in this one, but the answers you get are 1, -1, I, and -I. Those are the 4 answers you get if you distribute the 1 out and
The-
find all the cosines and sines.
The top one is 1, the third one is the -1.
Yeah. Yeah.
Then normalize the second and negativize the third.
How many questions like that are you going to put on the test?
Finding roots.
That would be 4.
Up to 4. Well, that would be the most number of roots you'd have.
Okay.
I'm gonna do. I don't want to do 5. I'm gonna do cube roots right now. Let's try that. I would definitely expect to see like a square root, cube root, or 4th root. Not a 5th root. Okay. So what's the first thing I have to do to this equation? Yeah? Put it all in trig form. Right 1, up 1. What's your radius?
45.
The radius is going to be 1, or square root of 2.
Square root of 2. So on the right side, your radius is root 2.
And then the
What's your angle?
45 degrees.
45 degrees.
Sorry. I was happy.
So right side is what we learned yesterday. So hopefully people are feeling okay with writing that in trig form. Now, what's going to end up on the left side when we have to write something in trig form generically and raise it to the 3rd power? Yep.
We're going to get r cubed, and then we'd have cosine 3 theta, and then plus I sine 3 theta.
Now, set the radius on the left equal to the radius on the right. Set the angle on the left equal to the angle on the right. So the radius on the left is r cubed. And what's 2 as a, what if you want to write it without the square root symbol? It's 2 to what power?
1/2.
Yeah. It's 2 to the 1/2. And now, what could you raise each side to get rid of this 3?
1/3,
1/3. Yep.
which it would put it up to the 1/6.
That's why I wrote that as a fractional exponent, so then you could see it was 2 to the 1/6, which if you want to put it as a root is
Over 2.
the what root of 2?
6th root.
6th root.
Oh.
Yep. Okay, so there's your radius. However you want to write it, either format is fine. All right, so that's going to be my same radius in all 3 answers that I write. What's going to be different? I'm going to have 3 different angles. What's the angle that's on the left?
The x value. Oh, sorry. I thought you said coordinate.
So what's the angle that's on the left side? Yep.
The angle that's on the left side is just 3 theta.
And what's the angle that's on the right side?
The one that's on the right side is 45 degrees. And then we have to do the plus 360 degrees.
Yep.
K.
Okay. Okay, now before we start filling into that formula, it's better if we get theta alone. So what do we have to do to get theta alone?
Divide by 3.
Divide by 3. This time I'm going to do it like this, because I can actually simplify all of it. What's 45 divided by 3?
15.
15. And what's 360 divided by 3?
120.
Yep. Now, what are the three values k is going to equal?
It's going to equal 1, 0, 1, and 2.
0, 1, 2. Now it's just tedious to just plug everything in. Okay, k equals 0. What's my radius going to be in this answer?
15 degrees.
Radius.
The radius is going
Oh,
to be the
6th root of 2.
6th root of 2.
6th root.
And when you plug in 0 for k, what's your angle?
15.
15. I sine 15. First answer. K equals 1. What's my radius?
It's going to be the same as before.
Same as before. And now plug in 1. What's 120 plus 15?
We're going to have 135.
Yep. All right, now plug in k equals 2.
It's
What's my radius?
same as before, and the angle is going to be 255.
240 plus 15 is 255. And those are your answers.
And you found that by subtracting 135 and 15 and adding 108.
Those angles? Nope. We plugged them into this formula.
Oh, okay, yeah.
Yeah. So plug them into that formula.
Here.
Okay. Yeah. Okay, so while you guys are at lunch, I'll put a list of topics in the video that are going to be on the test.
I have Uno. Oh, yours is in there.
Okay, so homework tonight is on the board.
I've never been working with Jack.
Not gonna have you worry about 17. And on 25 to 28, they mentioned doing something with a graph. Don't worry about the graph.